Well, we can't look at it until Sunday night.
Yeah, so since you asked about extra credit, by the way, do you know what today is?
Pi Day. So
Pi Day.
Pi.
We should have brought Pi. Who's in charge of that?
You.
So let me just show you this really quickly here. And I can't remember if you have access to this, but you will Sunday night.
Okay, Sunday night.
I guess I should share my screen. I'm not sharing my. Okay, so if you go in here to Math 1040, oh, you can actually, I think, see it there. Oh, maybe not. Oh, you know what? I think I forgot to copy it. Here, I'm going to borrow this from my, because it's exactly the same as for my 2040 class. You should see a simulation March Madness thing here. I forgot to import it. So let me talk about the simulation extra credit because that's the harder one to do. But basically, I've got some old lectures from my Math 1040 class, 3 of them here. But it looks like I've posted the same one twice. I'm doing the same pose. How about that? So the important thing to remember is, so right now there's a blank spot here. This is where I'm going to put the blank spreadsheet. When I find out Sunday night, will you all be watching the selection show? I won't watch it because I don't have cable, but I will find out immediately after. And I will post that here. So the important things to remember, you can do 2 brackets. One is a simulation bracket. The other one's just a regular bracket. Pick them. So the regular bracket is called personal probabilities. You can do anything you want. Simulation, I need to see your spreadsheet to get the full 3 points, okay? And so tell me your ESPN username. Just submit that as a comment, not as part of your spreadsheet. Also, in a comment, submit your final 4 teams, your final 2 teams, your champion, and make sure you attach the spreadsheet, okay? Also, make sure that you sign up on this group here, the tournament challenge bracket. So so make sure you tell me your ESPN username. It can be anything you want, like Pink Fairy Lady or something. I think that was somebody. But I don't know who that is, so tell me it's, Ashley or something, okay? So I've also got my 2014 bracket right there. If you want to see that bracket, I don't know how much that'll help you because there's different teams, but you can check it out, okay? So any questions about the extra credit? Okay? Yes?
Which section do the points go into?
The points go into your quizzes section.
Ooh.
Okay? So, yeah. Any other questions? Apparently I need to import that in ours. But yeah, so anyway, that's what it looks like. All right. So let's stop sharing. Okay. So we're going to talk today about Chapter 20. Which is hypothesis test for a mean. Okay? Now, an important question you should ask yourself is, do I know
The mean.
the population standard deviation? Okay? Nicole, there are only 2 answers to that question. What are the 2 answers? Yes or no? Don't you like being picked on first? Yes or no. Okay? If the answer is yes, do you know what distribution you're going to be using?
The z-test.
The z-test. Did you know that? No, the phone a friend thing worked pretty well, huh?
Wait, so today in that quiz you didn't.
I know. I know, the quiz was messed up.
Wait, so you had the sample standard deviation in the quiz?
Sometimes you'll know both, okay?
Yeah, but today.
But all I want to know, if the answer is no, what are you using?
The t-test.
The t-test. Now the equations are very similar. For the z-test, it's x bar minus mu over sigma over the square root of n. For the t-test, it's x bar minus mu over s over the square root of n.
And that's the same as the last equation that we used for last time. The Z was the same.
Yeah, this is the same Z equation
Okay.
that we've learned before. Okay? So here's what I want to do. Seems like we only get through one, but I'm going to do my best to get through a minimum of 2, maybe 3 hypothesis tests. Okay?
We're gonna do it on Excel today.
Yeah, let's do it on Excel. Okay? So these are the 2 main equations that you're going to focus on. I will say that the T is the one that chapter 20 focuses most on. Okay? But I want you to also be aware that you could use a Z test. Okay? Yes.
So the S and the T stands for standard deviation? Or what does that S stand for?
The S stands for sample standard deviation.
Okay, samples.
Sigma stands for population standard deviation. T stands for T, Z stands for normal. Okay? All right. I guess I haven't given you the whole thing, the whole spiel about the T distribution, have I?
No.
Oh, I don't think that's, haven't I?
Are you recording right now?
I am recording.
Okay.
So, here, just really quickly. This isn't in my notes, but the student T was distribution, I should say. The student T distribution was discovered by William Gossett. And he worked at a beer company. And he wrote this pseudonymously, not under his name. He just called it the student T distribution, and everybody's like, well, that's pretty cool. Okay? Now, so properties of the T distribution. Number 1, it is symmetric. Number 2, it is the shape changes based on the degrees of freedom. Why they call it degrees of freedom, I don't really know, but the degrees of freedom equals your sample size minus 1. Okay? What else? I'm doing this from memory. As your sample size increases, it looks more like the normal curve. Number 4, it's bell-shaped, but I'm going to say fatter than the normal distribution. Okay? So, whereas, and let me do it this way, if this is the normal distribution, so I'm going to use a Z for that, okay? We're getting a big light on the board.
Does that say fatter?
Fatter. Yeah, that helps. You don't see that light. If the black curve is the Z distribution, this blue curve would be the T distribution, okay? So they're both centered at 0, but you're going to have a fatter curve for the T distribution than you are the Z distribution, okay? And degrees of freedom, that's going to be an important thing to remember on the T distribution, okay? So, let's do an example here. So I'm going to share my screen. Okay? All right. So let's say the CDC says the mean cigarettes smoked per day by smokers is, can't type, 18.1. We obtain a simple random sample of 40 retired smokers and get a mean of 16.8 cigarettes per day and a standard deviation of 4.7 cigarettes. Using alpha equals 0.10, find out if retired smokers smoke less. Okay? So we're going to go through our 7 steps. So, Shire, do you remember what step number 1 was? List all the numbers. Okay? So the CDC says the mean cigarette smoke per day is 18.1. What is 18.1?
Okay, is that mu?
Is it?
Or is that X bar?
That's a good question. Is it mu or X bar? Should we vote? Who says it's mu? 1, 2, 3, 4, 5, 6, 7. Who says it's X bar? Shire, you didn't vote. You don't know. That's a guaranteed wrong answer, right? Okay, majority wins, it's mu. Why is it mu, Brenda? Because we're saying that's a population. The CDC should know, right? They're the ones who study smoking. Okay? All right, we obtained a simple random sample of 40 retired smokers. We're going to stick with Shire here. What's 40? N. Okay? 40 retired smokers get a mean of 16.8 cigarettes per day. What's 16.8? X bar. Okay, that makes it more, okay? Why is the X bar not mu?
Because it's a sample mean.
Okay, and how do we know it's a sample?
That's what they said they got out of the sample.
Out of how many people?
40.
The 40 people is your sample, right? Okay? And there's got a standard deviation of 4.7 cigarettes per day. What is 4.7? Which one? Is it sigma?
Yes.
Who says it's sigma?
No, it's the S.
Not similar.
One person says it's sigma. Who says it's something else? 3 people. What do you think it is, Tanner?
S,
S. Why is it S?
because it's the standard deviation of the sample.
Because that cigarette, those standard deviation comes from those 40 retired smokers, so it's S. Okay. Using alpha equals 0.10. That was easy because I gave it to you. Alpha equals 0.10. Okay. All right. Step number 2 is
Is it categorical or is it quantitative?
categorical or quantitative. Should we vote? Who says it's categorical? Nobody? Who says it's quantitative? Looks like everybody, except for somebody probably didn't raise their hand. Majority wins. It's quantitative. Okay. Step number 3. Who's got step number 3, Audrey?
We're gonna do the null hypothesis and the alternative hypothesis.
And the alternative hypothesis. What's the null hypothesis?
U equals 18.1.
Mu equals 18.1. The alternative is
U is less than or 18.1.
less than 18.1. Who agrees with Audrey? 1, 2, 3, 4, 5, 6, 7. Who disagrees? You were not listening. That's the problem. Okay. Audrey was correct. step number 4 is pick the test. So here's what I mean when I say pick the test, okay? I don't want to list all 6 choices, but is it a Z, is it a T, or is it a chi-square? And then tell me how you know. Say, so who votes for Z? Nobody? Who votes for T? 1, 2, 3, almost all the class. Who votes for chi-square? Okay, why is it a T?
Because we are given the sample standard deviation.
Okay, we can always find out the sample standard deviation because it's our sample, right? We don't know the population, so it's a T. So it's a T, it's a 1 sample T mean test, okay? And the formula is T equals X bar minus mu S over square root of N. Okay? And I'm going to underline that so it looks like a fraction. Okay? So, Riley, can you help me punch this through? I bet you can. I'm going to help you. We're going to be 95% confident.
So 16.8.
16.8, see, I knew you could do this. Minus what?
Minus
18.1.
Divided by 4.7.
4.7 square root of minus 40. See, don't you feel way more confident than you did? It just took seconds. Okay? All right, so I'm going to take my numerator, I'm going to divide it by my denominator, and I'm going to get a value of negative 1.74. Okay? What is step number 5? Find the p-value. Okay? Now, there are 2 methods for doing this. You need to know both methods. You have the chart, and you have the computer. Okay? All right. Which one do you want to learn first? Brenda? You want to do the chart first? Okay, so I've got the chart here, maybe somewhere. No, I don't. Yeah, I do right there. Okay, so you can see here I've got the random number table, I've got the normal distribution, and I've got the now, by the way, let's look at the normal distribution for just a moment. Okay? Which side is shaded on my normal distribution? The left side. Let's look at my t distribution. Which side is shaded on my t distribution? The right. Okay? Very important to pay attention to that. Okay?
I just have a quick random question. Why is there an Ireland flag up there?
Because Gossett worked for an Irish brewery, and he invented the student tea distribution.
Oh, really? Wow. Your permission in there.
Yeah, that's why. You did?
Yeah.
So you heard of William Gossett before?
Nope.
Yeah. So you learned something new today. All right, so you can kind of see that there, okay? All right, now let's go back here for a second. We forgot to mention our degrees of freedom here. Degrees of freedom in this case equals n minus 1. So 40 minus 1 is 39, okay? All right, so we're looking at 39 degrees of freedom, okay? You're going to find out you're not going to like this chart very well, okay? So we're going to 39 degrees of freedom, which is this line right here, okay? We're looking at this line, okay? And I got a value of negative 1.74. Well, one of the nice things about the t-distribution is it's symmetric, okay? We're going to learn a chi-square distribution later, and it's not symmetric, and then you're going to feel really bad because it's going to be not as easy as this, okay? So the idea here is I'm going to ignore the negative sign for a moment, okay? And what's going to happen here, so my t value here is negative 1.749, okay? So on the chart, what I'm going to do is I'm going to look for that value on this row here, 1.749. Okay, I'm going to go along here. Where does 1.749 fit? Oh, it fits in between these 2 values right here. Okay, you see that? So that means it fits in between those two values up at the top of the chart. Okay? So your p-value in this case, I can't get an exact value like I can on the normal distribution, but it's in between those two values, so therefore it's in between those two values. So your p-value is in between 0.025 and 0.05. Does that make sense? Okay, so I'm going to write this. So with the chart, the best you can do is your p-value is in between 0.025 and 0.05.
So you do the bigger number and then the smaller. Doesn't matter.
It does matter. Smaller numbers on the left. Okay? Now, by the way, what would Rick do? He would draw a picture, right? Okay, so when I'm drawing my picture, what am I drawing a picture of? A bell curve, which looks like the t-distribution, right? What's the mean of my bell curve? 0. I got a value of negative 1.74, didn't I? I want the area to the left. But the fact of the matter is, I can also look at the right side, 1.74, and I can get this area. That area is going to be it's going to be in between 2.5% and 5%. Now, one of the nice things about the computer is I can get an exact value. I don't have to bracket it. Okay? So, when I go here, sorry, back to here. Okay, the computer, if you were going to come up with a command for the t-distribution, what would you call it? T-dist, how about that? Equals t.dist, okay? Now, it asks, do you want the right tail, do you want a two-tailed test, or do you want the left tail? What do we want? We want the blue area here, right? Okay.
It shows the right.
So I want the left tail. Okay. I want the left tail. For X, I'm going to put in the t-score here. My degrees of freedom are 39. And you're almost always going to put true here. I don't think there's ever a case you won't put true. We want the cumulative distribution function. Do you remember what that was from back on chapter 6 or something? No, I'm not surprised. Okay, so the p-value I got was 0.044. Okay, which you'll notice here that is in between 2.5% and 5%. You see that? Okay.
Wait, so can you show us what we plug in on the computer one again? So it's t.dist, and then in the parentheses you do x bar.
And you have to decide is it a right tail or a left tail. Okay, so we're doing a left tail test. And you're putting in the t-score. Comma, your degrees of freedom. Degrees of freedom in this case is 39. And true.
Always.
Yeah, in this class it'll be always. Okay? And that gives you 0.044. Okay? What is step number 6?
Decide to reject it or to not reject.
And how do we know?
P-value is lower than reject.
If the p-value
So reject.
is low, okay, so let's think about it. Reject the null. Okay? Is my p-value, let's use this one here. Okay? The biggest it could be is 0.05. What's my alpha? 0.10, right? Is 0.05 lower than 0.10?
Yes.
So therefore, I reject the null. Okay? So I no longer believe this is true. I black it out. Okay, I don't believe that's true anymore. I don't believe that the retired smokers smoke 18 point cigarettes per day. So therefore, the conclusion is,
Wrong.
is it true that retired smokers smoke less? Ashley, can you give us a conclusion?
Yes, so if you reject the null, then it's.
Yes, there is evidence that
The mean
retired
smokers have a mean of 16 points, or have less than.
smoke less than regular smokers. Does that make sense?
So if you reject it, then there is evidence. If you don't reject it, then
There is not evidence.
okay.
Okay? That a good one? Yes. I kind of want to do two more. Brenda.
I don't know why. How did you find
It's
out?
just your sample size minus 1. That's all it is.
Why is it called degrees of freedom?
I don't know.
Like we're like independent. Like,
Freedom!
yeah, freedom.
Yeah, it's a weird term. I don't know why.
Okay, cool. So let's just pretend that our p-value is between 0.025 and 0.15. At that point, do we not reject? Because
Okay, so your p-value will not be between 0.025 and 0.15 because you got lots of things there.
like, well, I'm saying like my point is if the p-value like it's underneath the alpha.
Let's do this one. Let's pretend that our p-value is between 0.05 and 0.10. My alpha is still 0.10. Okay? My p-value is less than alpha, right? Less than 0.10. So reject or do not reject?
We still reject.
We still reject.
So
What if it's
my thought like my.
What if it's between 0.10 and 0.15?
So it's like. Oh. Because
It's more than 0.10, right?
No. Would it ever straddle? And then
No.
like straddle, like 0.08.
So like, thank
It
you.
won't straddle.
It'll either be all the options be completely under. Or
It'll be
options
all of them
completely-
above or below, right?
Okay.
Unless you pick a weird p-value, but I wouldn't do that. Like I'm going to pick a p-value of 0.03 just to make it really hard. No, I'm not going to do that. Okay? Yes.
But ultimately, we're comparing that piece score to that point.
We're comparing what?
We're comparing the p-score, the
p-value
to the 0.10.
to the alpha.
We're not using 0.05 at all. I mean,
We're not using 0.05 and all because I said to use 0.10. Because 40 is kind of a small sample size.
I didn't put 0.05 earlier, and I said, where does that have to do with it? Okay.
Yeah, there's 0.05 has nothing in this problem. Okay? Yes.
I have a question on the future.
Okay?
So I noticed that like once it gets to 40, it starts jumping.
The question on the point on the T-chart, what is it?
So once it gets 40, it just ends like 40, 50,
Yeah.
60, 70.
That's a good question. So what do you do if your sample size is 45?
Yeah.
You just go up or below.
Go up or down, just round to the nearest one. That's a good question. Okay? Yeah, so 40, 50, yeah. So if it's 42, you'd round it to 40. If it's 48, you'd round it to 50. And if it's 45, you'd still round it to 50. Okay? So we'll just follow regular rounding on that. Good question. Anything else? All right, let me see if I can find you a minimum of 1, if not 2. Oh, there's a good one. Okay, let's do another one. Do you want me to save this for you? So you can look at it over spring break? While you're on the beach in Hawaii on Southwest Airlines? You know, that's going to mess it up because they bought those new airplanes and then President Trump just grounded them all yesterday.
What?
Those were specifically meant for Hawaii.
Why?
You know, Southwest flies to Hawaii now. And they had those two crashes, the Air Ethiopia and the Lion Air. And that's the same model of airplane.
Oh my gosh.
And President Trump grounded it. And they've got 35 of those airplanes, and it was because they were going to Hawaii. That's why they got them. So anyway, so I don't know what they're going to do now. They'll have to use something else.
Wait, they built a new airplane and there's been 2 crashes with those airplanes
Within 6 months.
because of the airplane?
Well, nobody knows why.
Gosh.
Yeah. So it sounds like the new design, even though they're both 737s, so all Southwest planes are 737s, but this new airplane, they moved the engines forward, and so it messed up the weight and balance. And so they got this software that the plane can stall easier. And so there was some misreadings, and so the nose was diving because the plane thought it was going to stall, but it wasn't stalling. So the pilot's trying to pull it up and down, up and down, and it couldn't control it.
That's weird.
So yeah, anyway, they need to train the pilots better. But anyway, that's what it sounds like. All right. So the Wireless Association says the mean cell phone bill is $50.64. A market researcher believes a cell phone bill is different today and gets 12 random cell phones and finds the following data. Use alpha equal 0.05 to see if researcher is correct. Okay, 2425, 7007, 55, 38, 94. Yeah, isn't that nice?
It's not that bad.
All right. So, Landon, what do you think? What's the first step?
I think the first step is going to be to write down all the numbers.
Find the numbers.
I'd find the mean first because that's going to be the longest.
Landon, what are you doing?
All right, let's see. Okay,
Let's go through the words first.
Okay, Wireless Association says the mean cell phone bill is $50.64. That's true.
Are you sure that's new?
Yeah.
Okay, good.
Market researcher believes cell phone bill different today and gets 12 random cell phones. So N is 12.
N equals 12.
The following data is alpha is 0.05.
Alpha equals 0.05.
Now we can find our sample mean, which is the information you give us.
Okay, so how do we find this? What do we call our sample mean? X bar.
Equals
Average critical gauge. Want to think about that? Want to do the quiz?
enter.
So Brady, I just want you to know that I told everybody about you in my 2040 class.
Oh, you did?
Because I thought that was so funny. All right, so you're famous.
Oh, yeah.
All right, X bar is $65 and a penny.
And then we can find our
Sample standard deviation is
equals ST dev.
Sample.
S.
Make sure to do that.
do the dot S because it's a sample, right? What do we call that one? S. Okay, is there anything else?
Well, you could find your degrees of freedom.
Degrees of freedom, just in case, equals
11.
12 minus 1 is 11. Okay? All right, step number 2 is what, Ashley?
Is it quantitative or categorical?
And the answer is quantitative.
We're
Very
going
good.
to do a categorical.
Not in this chapter. We did that last time.
Okay.
Okay, just gonna pick on Suzette too. Gauge,
We have to take.
you have to take a test.
Find a null.
Find the null and the alternative. Okay, the null hypothesis is gauge.
N equals.
Mu equals, what'd you say? 50.64, and the alternative? Not equal to $2.64. Okay, step number 4 is what, Brenda? And is it a z, a t, a chi-square?
T.
T because population standard deviation. Okay, t equals, you do the rest? Remember your formula? It's on the board.
X bar minus mu over S or divided by 2.
Okay, can you punch the numbers in? Yeah.
Okay, so 65.012 minus 50.64 divided by 25.45 divided by square root of 12.
Okay, we'll underline that so it looks like that. Okay, 1.95. Step number 5 is what, Natalie? Nicole? Sorry?
Oh,
You don't remember? What is it, Shire?
what was the question?
Step number 5?
By the p-value.
Find the p-value. Now that you know that, Nicole, can you find the p-value? You don't know how? There's 2 methods. Chart or computer. You got some studying to do over spring break. Okay, which one do you want to do, the chart or the computer? You sure? The computer's easier.
Computer's easier?
Yeah.
Whoa,
Okay.
well, that means we need practice on the chart.
We'll do the chart too, but, okay, do you remember how to do the computer? No? Have you been listening?
I'm just being honest. No, I don't.
Okay, what's the command? Why am I having a hard time with your name? I can't remember.
Me?
Yeah,
Lindsay.
Lindsay.
2 equals t dot this.
Which one?
You'll do the first one. No, you're gonna do the second one.
It's a two-tailed test. Okay, now, by the way, let me just mention this on the two-tailed
Is
test.
it always gonna be two-tailed test? No.
No.
It's not equal.
Why do you know it's a two-tailed test?
Oh, because it's not equal.
Because the alternative. Okay, now, by the way, well, let me just show you a couple quick things on here. Okay, two-tailed test, we're going to do that, and your degrees of freedom
Which we found, which was.
is 11. Okay, now, 0.07. Another thing that I just want to point out is, let's pretend for a moment that this is negative. Watch what happens. Didn't work. The two-tailed test only works if it's positive. So if you get a negative number, multiply it, there's either multiply it by -1 to make it positive, or what you could also do is, if I have a positive number, I could do the t.dist, I could do a right-tailed test of that with 11 degrees of freedom, and then I multiply that times 2, that'll give me the same answer. Okay? So the left tail is expecting a negative, the right tail and the two tail are expecting positive numbers. Now I am curious if I did. Let's pretend this is negative.
Was it right tail and true tail in positive numbers?
The right tail and what tail? Right tail and.
Actually,
Did you say that again?
let me just check one more thing.
Left tail's negative?
Okay, oh yeah, so the two-tail always expects a positive number. If you have a negative number, it's not going to work. So you either make it negative or multiply it by -1, or you do either the right tail or the left tail test and double it. Does that make sense? Okay, are you going to nail that on the quiz in a week and a half? Okay, that was confident. All right, do you know how to use the chart? Because that'll be on the quiz when you get back in a week and a half. Okay, how do you do it? We've got a value of 1.95 and we got 11 degrees of freedom. Let's go to the chart. Okay. I'm going to 11 degrees of freedom. That's too low. 11 degrees of freedom. I'm on this row. What do I do?
What was the other number?
1.95.
So then you find that.
Find where 1.95 fits. Right there, correct? So your p-value is? So it's in between these two numbers.
So that it's.
1.95 is in between those two numbers, right? So your p-value, oh, so this is tricky. This is a good tricky one. So your p-value is between 0.025 and 0.05, right? P-value is in between 0.025 and 0.05. Now notice that 0.07 is not in between those two values. Why is that? Because I'm doing a two-tailed test. So you got to multiply it by 2. So now it's in between 0.05 and 0.10. Haha, that was a good one. Okay, so you got to double it. Okay, so this is the correct answer with the chart.
Okay.
This is the correct answer with the computer, and they match roughly. Okay, step number 6 is what, Audrey?
If the value is low, then the
Click the hole.
Is my p-value low? There's my alpha right there, right?
No.
No, so do not reject. And Colin, you're going to take us home with a conclusion.
So I'm going to say that there is not enough evidence that the phone bill is different today than it used to be.
Okay. Now notice we got $65. It was $50, but we're saying that's not a significant difference. Looks like it went up, kind of, right?
It looks like it went up a lot.
But why do you think we weren't able to find a difference? Why is $15 not significant? Because your standard deviation is $25, right? That's less than one standard deviation away. Right?
Yeah.
Okay. If my sample size was larger, perhaps it might have been. In fact, if my sample size was, say, 100, let's see if all my numbers change. Yeah. If my sample size was 100 phones, would it be significant? Yes, it would. Very highly significant. Look at that number, 1 times 10 to the minus 7. Okay? So this is where your sample size matters. Okay? So, quiz a week from Tuesday after we get back is going to be on chapter 20. remember to be able to tell the difference between a Z and a T. I wanted to do a Z, but I ran out of time. And your extra credit is due Wednesday night. Okay? It'll be posted Sunday night. Okay? See y'all. Have a great spring break.